Hello there, and welcome to Sleepy Cosmic Podcast, where we wander beneath velvet skies, following ancient light on its unhurried path through time. Tonight, we rest with the story of the rise and fall of dinosaurs, carried along by the rhythms of Earth and the wider cosmos. Their lives unfolded beneath the same stars we see today, though the constellations were tilted, the continents were scattered, and the nights were longer in ways we can scarcely imagine. If this kind of quiet wonder helps you rest, I'd be grateful if you tap like or subscribe, no pressure at all. And if you'd like, you can whisper your location or notice the time where you are now, joining countless listeners who drift together across different horizons under one sky. Now, dim the lights, maybe turn on a fan for a soft background hum, and let's ease into tonight's journey together. When we picture dinosaurs, we often think of enormous creatures striding across fern-filled valleys, their necks stretching into warm skies. Yet to imagine them fully, we must remember that their world was never separate from the stars. Every night above the vast forests and volcanic plains, the Milky Way spread like a river of frozen light. Our planet's deep time has always been nested within cosmic time, and the story of life on Earth cannot be told apart from the quiet turning of the heavens above. More than 230 million years ago, in the late Triassic, the first creatures we would recognize as dinosaurs began to stir. They were not giants yet, but small and agile, no larger than dogs. They moved under unfamiliar constellations, for the slow drift of Earth's axis had painted the sky differently. Even then, the cosmic microwave background, those ancient photons released when the universe was only a few 100,000 years old, still whispered faintly across space, reaching even the thin air above the Triassic world. The continents were bound together in a supercontinent called Pangaea, stretching from pole to pole. Along its inland deserts, the nights were vast and cold, and the stars appeared sharper than in humid coastal skies. Dinosaurs began here as minor players, sharing ground with crocodile-like reptiles and mammal-like cousins that prowled in the twilight. Perhaps they did not yet know dominance, but they carried quiet potential within their bones, a potential that would unfurl across millions of years. We sometimes imagine their world as static, but the Earth was alive with change. Volcanoes breathed out ash that painted sunsets red. Shallow seas receded, then crept back again, whispering along the edges of the land. Above, the moon tugged at tides as it does now, though it was a little closer then, glowing slightly larger in the sky. Its gentle pull slowed Earth's spin over eons, lengthening days, setting the rhythm of life. Even dinosaurs in their early stirrings lived by cycles of light and dark, warmth and cold, gravity and tide. Beneath those same skies, comets occasionally blazed across the heavens just as they do now. The Triassic night might have been pierced by a meteor shower, startling small creatures below, their instincts sharpened by fear of predators. It is a strange thought that some of those meteors were fragments of ancient collisions in the asteroid belt, silent echoes of events as old as the solar system itself. Astrophysicists still debate whether long-term changes in Earth's orbit, known as Milankovitch cycles, nudged climates in ways that opened ecological doors for dinosaurs. Perhaps slight tilts and wobbles, governed by gravitational whispers from Jupiter and Saturn, set the stage for their rise. Such shifts would have altered rainfall, deserts and forests, slowly changing where life could thrive. The dinosaurs stepped into these openings, just as starlight slipped into the openings of dark night skies. The fossil record tells us that the earliest dinosaurs lived in the southern parts of Pangaea, in what is now Argentina and Brazil. We picture them moving quietly among cycads and tall conifers, their small forms casting shadows beneath starlight. They were swift, perhaps feathered in a primitive way, though we cannot be certain. Later, descendants would bear plumes that shimmered in sunlight, but here the feathers, if they existed, were soft, hidden, not yet the banners of flight. Meanwhile, The universe above carried on with its vast business. Galaxies continued to collide and merge far away, unseen by any eye on Earth. Stars in our own Milky Way burned out and left behind white dwarfs or neutron stars, seeding the cosmos with heavier elements. The quiet breath of cosmic expansion pressed outward, imperceptible on human scales, yet constant and sure. Against such immensity, the fragile emergence of dinosaurs might seem small. But within deep time, every story is a thread, and the rise of these creatures would shape the course of life in ways still felt today. As the Triassic ended, great extinctions swept away many competitors. Volcanic floods released carbon dioxide and sulfur, skies darkened, seas warmed, ecosystems faltered. Yet from this turmoil, dinosaurs found room to grow. It is as if the universe had cleared a path, not by design, but by chance and rhythm. They stepped forward, guided not by foresight but by survival, carrying their story into the Jurassic that awaited. Even as we close our eyes tonight, we might picture that ancient world beneath a sky both strange and familiar. Stars shone down as they do now, and the quiet murmur of the cosmos pressed onward. Dinosaurs rose not only from the earth beneath them, but from the rhythms of the heavens that wrapped around them. Their beginning was not separate from starlight, but woven into it, like every story told upon this planet. When we drift further into the Triassic world, we find a planet still healing from earlier upheavals. Just before the age of dinosaurs began, Earth endured one of its most severe extinctions, the Permian-Triassic event, when much of life was swept away. Entire lineages of plants and animals disappeared, leaving ecological space open for something new to arise. Into this quiet vacancy stepped the earliest dinosaurs, small and unassuming, yet destined to carry their lineage through more than 160 million years. They began in warm, dry regions, among landscapes of red stone and spreading deserts. Rainfall was seasonal, and life clung to riverbanks and fertile valleys where green could take root. In these places, dinosaurs first stretched their limbs. They were not the massive creatures of later ages. Some walked on two legs, agile and lightly built. Others clung closer to the ground with claws ready for seizing small prey. Their bones were light, their movements swift, and their future uncertain. Above them, the skies told another story. The sun set over Pangaea, casting long shadows across wide plains, while the constellations overhead slowly drifted with the turning of Earth's axis. The stars were the same we know now, yet rearranged by time. Perhaps an early dinosaur lifted its head, eyes catching the faint glimmer of the Milky Way, though it could not know the scale of what it saw. That same band of light is the glow of billions of distant stars, their photons travelling for tens of thousands of years before touching Earth. Astrophysicists often remind us that the cosmic microwave background, the first light of the universe, is still present everywhere, even over those Triassic nights. Dinosaurs could never sense it, but it bathed them all the same, a soft sea of radiation more than 13 billion years old. Its temperature then was nearly identical to now, only a fraction above absolute zero, a reminder that the universe drifts slowly, without hurry. In the Triassic world, many animals competed for survival. Crocodile-like reptiles were often the dominant predators, snapping with armoured jaws along riverbanks. Mammal-like reptiles scurried in burrows and forests, the distant ancestors of our own kind. Dinosaurs, at first, were not rulers but survivors, learning to live alongside stronger rivals. Fossils from South America tell us of creatures like Herrerasaurus, a swift predator with sharp teeth, and Eoraptor, one of the earliest known species only a metre long. They did not yet stride as kings, but they carried new traits, upright posture, lighter frames, that gave them promise. At night, volcanic horizons glowed faintly red, painting skies with ash and light. Earth's mantle was restless, shifting plates and cracking Pangaea's surface. Perhaps some dinosaurs lived near these fiery places, their lives punctuated by tremors. The ash that rose into the sky might have dimmed the stars at times, though the brightest, Sirius, Arcturus, Vega, would still pierce the haze. In those nights, meteors traced quiet arcs, reminders that our planet is never isolated from the wider cosmos. One lesser-known fact is that Earth's days were shorter then. Hundreds of millions of years ago, a day lasted only about 22 hours, because Earth spun faster. The Moon's pull has gradually slowed that spin, lengthening days over eons. Dinosaurs lived by these shorter days, their bodies tuned to rhythms slightly different from ours. If we could stand beside them, we would find dawn and dusk arriving a little more quickly, night and day passing in a rhythm unfamiliar to our own. Climates too were shifting. Astrophysicists still debate how much Earth's orbit, stretched and tilted by the pull of Jupiter and Saturn, influenced the cycles of heat and dryness during the Triassic. Some suggest that these orbital wobbles triggered long droughts, then sudden rains, guiding which creatures could endure. For the dinosaurs, agility and adaptability may have been their quiet strength. They survived where others fell, ready to expand when the world allowed. Picture a Triassic plain beneath a velvet sky. Conifers and cycads rise in clusters, their shadows long in the twilight. Small dinosaurs move carefully among them, listening for the heavy tread of crocodile-like hunters. The air is filled with the calls of insects, the rustle of leaves, the trickle of water in shallow streams. Above, the stars shimmer in countless numbers. No city lights obscure them, no human gaze measures them. Only the silence of the night receives their glow. Perhaps it is humbling to realize that all of this unfolded while the Milky Way rotated slowly, carrying its spiral arms forward. A single rotation of our galaxy takes hundreds of millions of years. In the span of dinosaur history, the Milky Way has turned only a few times. Their entire saga is bound within just part of one galactic breath. To us, that is nearly endless. Yet to the cosmos, it is a quiet moment. The Triassic ended with change and upheaval. Volcanoes erupted on a vast scale, reshaping climates. Many creatures perished, but the dinosaurs, still modest in form, endured. They would step into the Jurassic transformed, ready to grow larger, to dominate landscapes, and to leave behind their uncertain beginnings. Their survival was not just an accident of Earth, but also of cosmic rhythm. The orbits, the tides, the tilt, the subtle balances of light and dark. And so, from small creatures beneath ancient stars, the dinosaurs began their long ascent. Their story is one of persistence across deep time, guided by forces both earthly and celestial, woven into the same fabric that carries the light above our heads tonight. As the Triassic world gave way to the Jurassic, the Earth entered a new rhythm. Forests grew denser, seas spread across lowlands, and climates softened. Where once small, lightly built reptiles darted across arid plains, now immense creatures began to rise. Dinosaurs stretched into their true form, filling the land with bodies so vast that their very presence reshaped the ecosystems around them. Picture a valley in the early Jurassic. Mist clings to ferns at dawn, and conifers tower like green spires against the horizon. In this quiet morning, a sauropod steps forward, its long neck sweeping above the trees, dew catching on its hide. This was a world of giants. Creatures like Volcanodon and later Brachiosaurus began to appear, stretching to lengths never seen before. Their size was not just an accident, but a response to abundance. Thick forests provided endless food, and long necks allowed them to reach higher than any competitor. The Milky Way arched over these valleys at night, a silver river of stars flowing through velvet skies. Perhaps these immense animals never noticed, but we might imagine their shadows cast under moonlight, their slow movements echoing the unhurried drift of galaxies. Above them, stars lived and died. Some collapsed into neutron stars, compact as cities yet heavier than suns. Others swelled into red giants, scattering dust that drifted across interstellar space. The cycles of the cosmos continued while Earth's valleys filled with life. A mainstream fact about this time is that oxygen levels in the atmosphere rose, likely supporting larger bodies and more active metabolisms. Ferns, cycads, and towering conifers spread in lush forests, pulling carbon dioxide from the air. With each breath, dinosaurs inhaled the products of ancient stars, for the oxygen in Earth's air was forged in stellar hearts long before their time. A lesser-known detail is the role of insect pollinators even before flowering plants fully emerged. While angiosperms had not yet appeared, beetles and other insects already formed part of a quiet system, feeding on pollen and spores. The buzzing of wings beneath Jurassic nights might have been as constant as the stars themselves, weaving subtle threads in the ecosystem that nurtured giants. Yet all was not stable. Earth itself was restless. The supercontinent Pangaea had begun to split apart, opening rifts that would grow into the Atlantic Ocean. The continents, once locked together, drifted slowly on molten currents beneath the crust. In the night sky, the stars shifted ever so slightly as Earth's rotation and axis precession traced new arcs. Astrophysicists still debate how much these continental rearrangements altered ocean currents and global climates, but it is likely they guided where forests thrived and where deserts spread. Dinosaurs lived not just on land, but in the currents of climate set by drifting continents. Predators, too, expanded. Theropods, swift and cunning, grew larger. Some became apex hunters, their teeth serrated like blades. They stalked the forests and plains, their roars perhaps echoing through canyons. Yet they remained balanced by prey, by herds of sauropods and stegosaurs, by armoured dinosaurs whose plates and spikes glinted beneath the sun. This balance created ecosystems of remarkable stability, lasting millions of years. At night, comets traced fire through the heavens. A fragment of ice and dust wandering from the outer solar system would burn in Earth's sky for a moment, a fleeting visitor from afar. Dinosaurs may not have looked upward, but such events remind us that Earth has never been isolated. The same skies we watch today stretched above them, alive with meteors, auroras, and the glow of stars. In the Jurassic, volcanic activity continued to shape the world. Lava flowed across rifts, ash fell like snow, and sulphur-coloured sunsets. For those who lived beneath, skies may have shifted from bright blue to hazy red. We know that eruptions can cool the climate by sending fine particles into the stratosphere, reflecting sunlight away. Astrophysicists still debate whether such episodes guided evolutionary turns, pushing certain groups of dinosaurs to adapt while others declined. Imagine lying quietly in a Jurassic meadow, listening to the breath of giants in the distance. Ferns rustle in warm breezes, insects hum, and above you, the sky deepens into night. Through the stillness, the band of the Milky Way spreads, its stars shimmering. Some of that light has travelled thousands of years, arriving in that moment to touch the eyes of creatures who could never grasp its scale. Yet the same photons, the same quiet glow, continue across time to us now. The rise of the Jurassic giants was not inevitable. It came through chance, adaptation, and opportunity, woven with cosmic rhythms of oxygen, gravity, and climate. Their flourishing reveals how deeply Earth's story is tied to the greater cosmos. Stars made their bones, continents carried their herds, orbital cycles shaped their skies. Dinosaurs lived within this vast web, their steps echoing in time with the slow turning of galaxies. As we drift further into the Jurassic, we notice that the rise of dinosaurs was guided not only by forests and prey, but also by the larger rhythms of Earth itself. Our planet is never still. It tilts, it wobbles, it traces an orbit that changes ever so slightly under the gravity of distant planets. These quiet shifts, known as Milankovitch cycles, alter the distribution of sunlight, creating long rhythms of ice, drought, and warmth. Even without knowing, dinosaurs lived by these celestial patterns. Their migrations, their feeding grounds, even the timing of their breeding may have been whispered into being by the pull of Jupiter and Saturn far away. The Earth tilts at about 23.5 degrees today, giving us our seasons. Yet over tens of thousands of years that tilt sways a little, sometimes more, sometimes less. When the tilt is stronger, summers grow hotter and winters colder. When it lessens, seasons soften. Astrophysicists still debate just how powerful these changes were for Jurassic life, but the evidence suggests they nudged climates in ways that shaped ecosystems. Imagine herds of sauropods wandering farther north in warmer cycles, then retreating south when winters stretch longer. Another rhythm is Earth's slow precession, a gentle wobble in its axis, like a spinning top leaning and swaying. Over thousands of years, this changes the timing of seasons relative to Earth's orbit. In the Jurassic, such cycles may have turned lush valleys into dry plains and then back again, forcing creatures to adapt or perish. Dinosaurs were perhaps especially resilient because of their range of body sizes and strategies. Small, swift forms could flee to new regions, while large sauropods could travel great distances in search of food. Above these wandering herds, the night sky marked its own cycles. Constellations drifted slightly across centuries, though they remained recognizable. The stars of Orion, of Scorpius, of the Southern Cross, all shone above Jurassic plains, though shifted in position compared to our modern skies. If we could stand beside a herd of Diplodocus at twilight, we would see those same stars rising, a continuity across deep time. The thought brings a hush. Dinosaurs and humans, separated by millions of years yet gazing at the same constellations. A mainstream scientific fact is that even now, Earth's orbit around the Sun is not a perfect circle, but an ellipse that slowly changes in shape. At times it is nearly round, at others more stretched. This affects how much sunlight reaches the poles, influencing ice and climate. The same was true in the Jurassic. Quiet, gradual changes in orbit altered the pulse of life, far beyond the awareness of any creature walking the ground. A lesser-known detail is that fossils in certain sedimentary layers show repeating patterns of growth stress, thin rings in fossilized bones and plants that match the timing of orbital cycles. In other words, even the bones of dinosaurs record the whisper of celestial rhythms, like tiny calendars etched in living tissue. When we study these fossils, we are not only learning of dinosaurs but of Earth's dance through the solar system. It remains uncertain, however, just how strong these rhythms were compared to other forces: volcanoes, drifting continents, shifting seas. Astrophysicists and paleoclimatologists continue to debate whether orbital cycles were the main driver of climate change or just one thread among many. What we know for certain is that life on Earth has always been tuned to the cosmos, responding in ways both subtle and profound. Picture, if you will, a quiet Jurassic night on a floodplain. The river bends lazily, reflecting the glow of the moon. Frogs croak softly, and the wind brushes tall ferns. A stegosaurus rests in the shadows, its plate silhouetted against starlight. Above, the Milky Way stretches wide, its arc unbroken by city lights. The stars that shine there are in the same spiral arm we inhabit today, the Orion arm of the galaxy. Yet back then, the entire solar system was slightly closer to the galactic centre, tracing its orbit with slow precision. Dinosaurs never felt this drift, but their entire age fits within a single sweep of our galaxy's rotation. From their first steps in the Triassic to their extinction in the Cretaceous, the Milky Way turned perhaps a third of one circle. Their saga, immense in our eyes, was only a gesture in galactic time. This humbling perspective helps us rest, reminding us that even the grandest eras pass quietly in the cosmos. The rhythms of Earth's tilt, orbit and wobble were like a background song, inaudible yet ever present. Dinosaurs moved, grazed, and survived within that song, and we, millions of years later, still live under the same cycles. Winters deepen, summers soften, climates shift, all because of orbital whispers written into the sky. In this way, the story of dinosaurs is not only their own, it is also ours, for we share the same celestial clock that measured their days. From the quiet sway of orbital rhythms, we move closer now to the living creatures who carried the Jurassic world upon their backs. In these forests and valleys, dinosaurs grew into towering forms and honed their predatory skills. The land was alive with giants and hunters, each bound by the same cycles of sun and starlight. Their footsteps echoed across fern-filled clearings, while the constellations wheeled above in slow silence. Sauropods rose as the true giants of this era. Their long necks stretched toward the highest branches of conifers, stripping them clean with sweeping motions. Some species, like Brachiosaurus, stood tall enough that their heads might have brushed the lower canopy, as if reaching into the sky itself. Their immense bodies required endless food, so they travelled in herds, moving steadily through forests. We can imagine the ground trembling as dozens of these creatures passed, their shadows long beneath the glow of a rising moon. Predators followed. The theropods, lean and swift, sharpened their place as hunters. Allosaurus, one of the most feared of the Jurassic, prowled valleys where sauropods gathered. Its teeth, curved and serrated, could tear through flesh, while its strong legs carried it with bursts of speed. Perhaps in twilight one could hear the crash of pursuit, the low bellow of prey, and the silence afterward. The balance of life was delicate, each giant herbivore matched by a cunning predator, each predator reliant on the herds it shadowed. Yet these creatures were not isolated from the wider cosmos. Their daily lives unfolded under skies shaped by the sun's energy. The Earth's orbit determined the length of days and seasons, while the moon pulled quietly on tides, setting rhythms that spread inland through rivers and rainfall. The same moon we see tonight, slightly closer then, glowed above their world. Its pale light silvered the scales and feathers of dinosaurs as they moved through the night. A mainstream scientific fact reminds us that Earth's gravity, together with the moon's, causes the phenomenon of tidal locking. Just as the moon shows us only one face today, it did so in the Jurassic. Dinosaurs never saw the far side, just as we cannot without spacecraft. To them, the moon was a constant, steady companion, rising and setting with a rhythm that never changed across millions of years. A lesser-known detail is that some paleontologists believe sauropods may have migrated seasonally, following rains and fresh growth, much like modern herds of elephants or wildebeest. These movements may have spanned hundreds of kilometres, guided perhaps by memory or instinct, but also aligned with the cycles of rainfall created by orbital shifts. When skies darkened with storms, sauropods lifted their heads, sensing the shift in wind, the promise of water. Astrophysicists still debate how much the sun's output itself has varied over deep time. Though generally stable, our star flickers slightly in cycles, with periods of stronger or weaker radiation. Perhaps in the Jurassic, subtle changes in solar activity nudged climates in ways we cannot fully measure. A faint cooling, a soft warming, passed down through clouds, rainfall and plant growth, shaping the lives of creatures far below. At night, predators may have moved more easily under starlight. Without human lights, the skies were dark and brilliant. The Milky Way spread overhead, a quiet beacon stretching from horizon to horizon. Insects hummed, frogs sang, and the faint cry of a distant theropod echoed against cliffs. We might imagine lying quietly in the grass, listening to their world, seeing the same stars they never noticed. It is humbling to recall that while these creatures reigned, galaxies far beyond were colliding. Black holes were devouring stars and supernovae were scattering heavy elements into space. The dinosaurs' story was immense, but it was also local, confined to one planet. Yet that planet was never separate. Their bones were built of calcium forged in ancient stars. Their breath was oxygen born of stellar fire. Even their shadows stretching across the ground were cast by light that had travelled 8 minutes from the sun. Perhaps one evening, a herd of stegosaurs lingered at a riverbank. Their plates caught the last golden light as the sun dipped, while above them the first stars began to shine. Across millions of years, such evenings repeated, unhurried and unnoticed. Dinosaurs lived not only in the scale of days and years, but within the grand cycles of earth and sky. Their predators and prey enacted dramas beneath the same constellations that we, much later, would name. The age of giants and hunters reminds us that life always adapts to the stage set by the cosmos. The earth tilts, the sun glows, the moon pulls, the stars drift, and life responds. Dinosaurs were not only creatures of the land, but of these celestial rhythms. Their roars and footsteps were as much a part of Earth's music as the whisper of wind in ferns or the faint shimmer of starlight on water. Beyond the forests and plains of the Jurassic, the oceans carried their own influence, shaping the rise of life on land. Dinosaurs walked the continents, but the pulse of the seas was never far from them. Water cycles, tides, and shifting coastlines determined which regions blossomed with plants and which fell silent into drought. Even the quiet tug of the moon guided these rhythms, linking the deep oceans to the shallow valleys where dinosaurs grazed. The seas of that age were not the vast familiar shapes we see on modern maps. Pangaea had begun to fracture, and as rifts opened, shallow seas spread across lowlands. Warm and nutrient-rich, these waters nourished reefs of corals and shellfish, which in turn fed marine reptiles and fish. Their abundance influenced the land, for winds carried moisture inland, and rivers drained nutrients back toward the coast. The fortunes of dinosaurs, though they walked on dry earth, were tied to the rise and fall of these ancient waters. A mainstream fact is that tides are caused primarily by the moon's gravitational pull, with the sun adding its own influence. In the Jurassic, as today, the ocean's surface bulged gently toward and away from the moon. This rhythm echoed far beyond the shore. Rainfall patterns and coastal climates shifted with sea levels, creating belts of green or arid land where dinosaurs either thrived or perished. A lesser-known detail is that the Jurassic seas held peculiar creatures known as ammonites, spiral-shelled relatives of modern squid. These animals flourished in countless forms, their coiled shells drifting with the currents. Their abundance is so reliable that paleontologists use their fossils to date layers of rock. While dinosaurs walk the land, ammonites pulse through the seas, their silent journeys marking time as surely as the stars above. Astrophysicists still debate the long reach of cosmic events into Earth's climate, even into its oceans. Some suggest that cycles in solar activity, slight variations in the sun's brightness, may have influenced rainfall and ocean temperatures. A faint dimming of sunlight could have cooled waters, while brighter cycles may have warmed them, shifting ecosystems. Such subtleties might have set the stage for droughts or floods that dinosaurs experienced far from the coast. Imagine standing at the edge of a Jurassic shoreline. The water laps gently, its surface golden under a setting sun. Pterosaurs wheel overhead, their wings catching the light as they dive for fish. Beyond the breakers, ichthyosaurs and plesiosaurs rise to breathe, their forms glistening before vanishing again. Inland, the cries of dinosaurs drift faintly across the wind, tied to this same water, dependent on its cycles. The moon would rise soon after, glowing brighter than we see it now, since it was closer to Earth by several thousand kilometers. Its reflection stretched in a silver path across the waves. Dinosaurs inland might not have noticed, yet their nights and days were shaped by the rainfall drawn from these seas, the moisture that nurtured their forests. The moon's silent pull was a bridge between ocean and land. Connecting reptiles that soared in the air, swam in the sea and roamed the ground. Volcanoes also played their part, pouring lava and gases into the air that mingled with the ocean. Carbon dioxide, released in vast quantities, dissolved into seawater, shifting chemistry and altering currents. At times, the seas may have warmed dramatically, sending ripples through ecosystems. The balance between land and ocean life was delicate. Dinosaurs thrived when forests grew thick, but forests needed rain, and rain was born from seas. To close your eyes and drift back to this time is to hear two worlds at once, the hush of waves rolling endlessly and the distant rumble of giants across plains. Both were part of the same song. The oceans whispered to the land through clouds, tides and winds. Dinosaurs were listeners in that song, moving to its rhythms whether they knew it or not. And above it all, the stars carried their own reflection. Oceans at night became mirrors for the heavens, doubling the constellations across their surface. The Milky Way stretched overhead and shimmered below as if the sky and sea had merged. We can imagine that a quiet ammonite drifting in darkness, or a dinosaur pausing to drink from a tide-fed pool, were surrounded by that infinite reflection. The rise of dinosaurs was not only about strength and size, it was also about patience within cycles. Seas swelling and retreating, tides guided by the moon, storms drifting across continents, galaxies moving in silence above. In the unhurried music of these rhythms, dinosaurs found their place, carried forward by oceans they never entered, yet could never escape. In the quiet unfolding of the Jurassic, something delicate began to stir among the branches and shadows. While giants strode across valleys and predators hunted with teeth and claw, small creatures took to the air in ways that hinted at a future beyond the age of reptiles. Feathers, soft and primitive at first, began to appear, not for flight but for warmth and display. Over time, these feathery coverings shaped the lineage that would eventually lead to birds. The earliest known of these feathered creatures, like Archaeopteryx, appeared in the late Jurassic. Fossils show wings fringed with delicate plumes, their patterns preserved in fine stone. They were not yet the masters of the sky we know today, but they could glide between trees or flap short distances, escaping predators or chasing insects. Imagine twilight in a Jurassic forest. A small feathered reptile leaps from a branch, wings catching the last glow of sunlight, before settling silently on another tree. The air was alive not only with the rustle of ferns, but also with these first, uncertain flights. The presence of feathers marked a turning point. Warm coverings meant creatures could regulate their temperature better, surviving cool nights when the stars stretched brilliantly overhead. The Earth spun more quickly then, its days a little shorter, so nights arrived sooner, and warmth mattered. Feathers also opened the door to display, bright patches or shimmering plumes that caught the eye of potential mates. Even in an age of giants, beauty played its part, whispered quietly in moonlit forests. Above them, the cosmos continued unchanged. The constellations glimmered, their positions subtly different from today, yet still familiar in form. The Milky Way glowed like a soft river, reflecting in shallow lakes. Perhaps these small feathered creatures, perched in trees, paused to notice the glow, tilting their heads toward a sky filled with meteors streaking quietly across. Astrophysicists remind us that Earth regularly passes through debris fields left by comets, creating meteor showers. Dinosaurs and their feathered kin would have seen the same showers we see today, though under skies unbroken by artificial light. A mainstream fact is that feathers are made of keratin, the same protein found in hair, claws and scales. Their evolution was gradual, with early feathers resembling downy tufts rather than flight-ready veins. Over millions of years, these structures diversified, serving not just for warmth but for maneuvering in the air. A lesser-known detail is that even some non-avian dinosaurs, like small raptors, bore feathers. Fossils from China reveal patterns of fine plumage along arms and tails, suggesting that feathers were more widespread than once thought. These creatures may have darted beneath starlit skies, their feathers glowing faintly in the moonlight long before birds themselves truly took wing. Still, much remains uncertain. Paleontologists and evolutionary biologists debate whether flight emerged once or multiple times in different lineages, and whether Archaeopteryx was truly the first bird or merely a side branch. The truth may remain hidden, locked in stone layers yet to be uncovered. But what we do know is that the seeds of flight were planted in this era, carried quietly on the wind. Imagine a Jurassic night deep in a conifer forest. The air is cool and mist curls above the ground. A small feathered dinosaur clings to a branch, its eyes bright, listening to the distant call of a predator. Above, the moon hangs large, casting silver light. The creature spreads its primitive wings and glides to safety, disappearing into the shadows. In that simple movement, the future of avian life has begun. Meanwhile, far beyond Earth, stars continued their endless cycles. Some swelled into giants before collapsing into supernovae, scattering calcium, iron and oxygen across space, the very elements that built bones, blood and feathers. Galaxies merged in silence, shaping the large-scale structure of the universe. Dinosaurs, unaware, were part of this cosmic lineage, their small flights echoing in a universe filled with motion. The rise of feathers was subtle compared to the thundering footsteps of giants, yet it carried a significance that would outlast them all. For while most dinosaur lineages would vanish at the end of the Cretaceous, the feathered ones endured, transforming into birds that now fill our skies. Every sparrow, every heron, every gull at the shoreline is a quiet echo of that Jurassic forest, when feathers first shimmered beneath starlight. And so, as giants ruled the ground, the seeds of another kingdom were sown in silence above. The sky was opening slowly, feather by feather, under the same constellations that we gaze upon tonight. As the Jurassic stretched onward, the continents themselves began to drift, reshaping the stage beneath the dinosaurs' feet. The supercontinent Pangaea, once a single vast expanse of land, was breaking apart. Rifts opened, seas spread, and land masses drifted slowly into new positions. Dinosaurs, whether they knew it or not, were passengers on these immense rafts of rock, carried along by currents in Earth's mantle. The shifting ground beneath them echoed the drifting of stars above. The movements of continents are measured in centimetres per year, slower than the growth of fingernails. Yet over millions of years, they transform the entire face of the planet. In the Jurassic, these movements opened the Atlantic Ocean. Valleys split, lava poured from cracks, and shallow waters seeped in. What had once been continuous land became scattered islands and coasts. For dinosaurs, this meant migration routes changed, habitats split, and populations diverged. Where once a herd might roam across a continent, now mountains or seas rose to divide them. Above, the night sky reflected its own changes. The constellations appeared to turn in their eternal cycles, though in truth, it was Earth itself that wobbled and precessed. Dinosaurs grazing beneath these skies may not have sensed the slow turning, but it marked their lives nonetheless. The stars shifted positions over millennia, so that the sky over a Jurassic sauropod was not quite the same as the one we know. Yet the Milky Way remained constant, a broad, luminous band tying Earth's drifting continents to the greater cosmos. A mainstream scientific fact is that plate tectonics, the movement of Earth's outer shell, drives earthquakes, volcanoes, and the distribution of continents. Without it, our planet would lack mountain ranges and long-term recycling of nutrients. In the Jurassic, this same process shaped the environments that allowed dinosaurs to flourish. A lesser-known detail is that the opening rift valleys of the Atlantic left behind basalt plains and shallow lakes where fossils are often found today. Some of the earliest feathered dinosaurs and small mammals were preserved in these rift basins, their bones settled quietly in lake bed mud. These places, once fractures in the continent, became silent archives of life. Astrophysicists still debate the influence of continental drift on Earth's climate over deep time. As land masses moved, they altered the circulation of oceans and winds. Some argue that the spread of shallow seas across the continents created warmer, more humid climates, while others suggest that new mountain ranges redirected rainfall. For dinosaurs, the results were direct: lush forests in some places, expanding deserts in others, corridors of green that guided their movements like rivers through stone. Imagine a herd of Diplodocus wandering across a wide floodplain. To the east, a ridge of fresh basalt rises where the land has split. Smoke lingers from volcanic vents, glowing faintly at dusk. The air carries a tang of ash, while new rivers cut across the plain. Above, the first stars emerge, their light unbothered by the shifting ground below. To the dinosaurs, these changes were part of the only world they knew. Yet we, looking back, see continents drifting like ships across an endless ocean of time. The slow rending of Pangaea also shaped evolution. As populations were divided, they adapted to their new environments, giving rise to distinct species. The story of life is often a story of separation, where isolation fosters change. In this way, the drifting continents became invisible sculptors of diversity, carving new lineages from the old. To close your eyes and drift with this thought is to imagine continents as vast rafts floating on glowing seas of mantle. On each raft, herds of dinosaurs moved slowly, unaware of the motion beneath. Overhead, galaxies swirled in their own drift, stars tugged by gravity into spirals and clusters. Both Earth and cosmos shared this restlessness, a slow expansion, a steady reconfiguration of forms. And so, as the Jurassic passed into the Cretaceous, Earth's face was no longer one but many. Dinosaurs roamed across continents that had begun to resemble the world we know, though not yet fully. They carried their legacy forward on moving ground, under shifting skies, a reminder that nothing, land, star, or life, remained still for long. The drifting of continents did more than change coastlines. It also set the stage for Earth's restless fire to rise. Volcanism became a constant presence, shaping landscapes, altering climates, and whispering into the very fate of dinosaurs. Where rift valleys widened, lava welled up, spreading in broad sheets across the land. Where subduction zones deepened, volcanoes rose like fiery mountains. To live in the age of dinosaurs was to live on a world that breathed heat from within. Imagine twilight on a Jurassic plain, the horizon glowing faint red. In the distance, a volcano exhales a steady plume of ash. By day, its slopes are dark with fresh lava. By night, its summit flickers with fire, a beacon beneath the stars. Dinosaurs grazed in the valleys nearby, accustomed to these rhythms. For them, eruptions were not rare events, but recurring parts of the landscape, much as storms or floods. The impact of volcanism was far-reaching. Ash carried minerals that fertilized soils, allowing forests to rebound with surprising speed. Yet the same eruptions also filled skies with particles, cooling the climate by veiling the sun. Whole years may have passed beneath dimmer skies, plants struggling, herds thinning. The balance between plenty and famine was fragile, and volcanoes tipped the scales. A mainstream fact is that volcanic eruptions can release vast amounts of carbon dioxide and sulfur dioxide. The former warms the planet over long spans, while the latter cools it in the short term. This duality creates sudden shifts, years of chill followed by epochs of warmth. Dinosaurs lived through such cycles, adapting or moving as needed. A lesser-known detail is that giant volcanic provinces, called flood basalts, erupted during the late Triassic and again later in the Cretaceous. These outpourings were not single events, but long episodes lasting hundreds of thousands of years. They released enough gas to alter global climate, possibly triggering extinctions. Some paleontologists suggest that these volcanic pulses cleared the way for dinosaurs' rise, and later may have contributed to their fall. Astrophysicists still debate how volcanic ash interacts with the upper atmosphere when combined with cosmic dust. Some argue that incoming micrometeorites may have mingled with volcanic haze, amplifying cooling effects. Others doubt the scale of this influence, yet the idea remains that Earth's climate is never shaped by a single force, but by many, some born of fire, others falling from space. Picture again a dinosaur landscape beneath volcanic skies. Herds of stegosaurs move slowly, their plates catching the last rays of sunlight through haze. Pterosaurs circle overhead, their wings disappearing into drifting ash. Night falls, and the stars emerge faintly, muted by the veil. The moon glows reddish, its light scattered by particles. For days or months the skies remain dim, the rhythms of plants and animals shifted by this quiet shadow. Yet life endured. Forests regrew, herds recovered, predators adapted. The resilience of dinosaurs was remarkable. Even as Earth trembled and exhaled, they found ways to continue, to graze, to hunt, to raise their young beneath uncertain skies. In this way, volcanism was both destroyer and creator, reshaping the world again and again. Far beyond Earth, the universe echoed this cycle. Stars themselves erupted as supernovae, scattering heavy elements into space. Black holes fed on gas, releasing energy across galaxies. The fire of Earth's volcanoes was small compared to these cosmic furnaces, yet both were part of the same pattern. Destruction leading to renewal, endings giving way to beginnings. The dinosaurs' world was therefore one of constant flux. Continents drifted, seas spread, volcanoes roared, and skies dimmed and cleared. Their survival depended on patience and adaptation, on enduring the silence after the ash. We, looking back, can see that each volcanic eruption was not only a local event but a thread in the wider fabric, woven together with cosmic dust, starlight, and time itself. And so, in the heart of fire and shadow, the age of dinosaurs deepened. Their story pressed onward, even as Earth's breath of lava reminded all life that nothing lasts unchanged. Beneath the stars, under skies painted with ash, they continued their long journey through deep time. Through fire and shifting seas, the dinosaurs spread into an astonishing variety of forms. The Jurassic and Cretaceous landscapes were alive with an abundance of shapes and strategies, each creature fitting itself into the niches of its world. From tiny hunters darting among ferns to colossal sauropods lumbering across plains, their diversity was a quiet triumph of adaptation. Imagine a wide valley just after dawn. Mist curls above the ground, the air rich with the scent of conifers. A herd of iguanodonts grazes, their beaks clipping leaves with rhythmic steadiness. Nearby, armoured ankylosaurs shuffle through undergrowth, their heavy tails swaying like pendulums. Above, pterosaurs wheel in slow arcs, scanning for fish in shallow pools. Each creature moves with a roll, grazers clearing plants, predators keeping herds in check, scavengers sweeping clean what is left behind. Together they form an ecosystem balanced like the stars in a constellation. The predators of this age were equally varied. Raptors with sickle claws stalked in packs, clever and quick. Larger theropods, like the fearsome tyrannosaur relatives of the late Cretaceous, ruled with power and presence. Yet smaller hunters thrived too, some feathered, some sleek and scaled, each finding prey suited to their size. No single form defined dinosaurs, their strength lay in diversity. A mainstream scientific fact is that ecosystems flourish most when species fill many roles, preventing imbalance. Dinosaurs embodied this principle across their long reign. Their range of body sizes, feeding habits, and habitats created resilient systems able to withstand droughts, eruptions, and shifting climates. A lesser-known detail is that some dinosaurs evolved to specialize in surprising ways. Tiny theropods with elongated arms and feathered bodies may have leapt to snatch insects in the air. Others, like the duck-billed hadrosaurs, developed elaborate crests that may have acted as resonating chambers for sound, allowing them to call across distances. The night air of the Cretaceous may have been filled not only with footsteps and rustling leaves, but also with eerie, resonant calls echoing beneath the stars. Astrophysicists still debate the timing and drivers of evolutionary bursts. Some suggest that cycles in Earth's orbit, nudging climates toward change, created openings for new species to arise. Others argue that sheer chance, a mutation in a single egg, could spark an entirely new lineage. Both may be true, life responding to the rhythms of the cosmos, yet also to the quiet accidents of its own code. Picture a moonlit scene by an inland lake. A hadrosaur herd stands along the shore, their silhouettes dark against the water. One lifts its head and releases a call, the sound rolling across the valley like a horn. In the silence that follows, a ripple of starlight glimmers on the surface of the lake. Somewhere in the distance, a predator answers with silence, biding its time. The balance of life continues, guided by voices, instincts, and the turning of Earth beneath the stars. What is striking is how deeply this diversity endured. For more than 160 million years, dinosaurs adapted to every continent, every climate, every shift of land and sea. They were not fragile rulers waiting to fall. They were resilient, branching into forms we continue to discover in stone. Even now, new fossils reveal creatures we had not imagined. Horned giants, spined predators, tiny feathered hunters frozen in amber. Each adds to the picture of an age when Earth was theirs. Above them, galaxies spun in silence. The Milky Way turned slowly, its arms carrying billions of stars through unhurried cycles. To us, the dinosaur age is a vast stretch of time. To the galaxy, it was a partial breath. Yet within that breath, life on Earth achieved one of its most remarkable experiments in form and variety. When we gaze at fossils today, we are not only seeing bones, but glimpses of adaptation across deep time. Each ridge and hollow, each curve of a crest or plate, is a story of survival written in stone. The dinosaurs were not a single kind of creature, but a chorus of possibilities, harmonizing beneath ancient skies. Their diversity was their strength, their answer to a restless Earth and a drifting cosmos. For millions of years, it was enough. And so the plains, forests and shores of that time were never silent, but filled with the sound of countless forms living, feeding and fading beneath the stars. As the age of dinosaurs deepened, seas spread across the continents in quiet waves, flooding lowlands and carving inland oceans. These waters stretched far into the heart of land masses, turning prairies into shallow bays and carving channels that linked distant regions. The Earth of the Cretaceous was not a planet of sharp divisions between land and sea, but a world of soft margins, where tides reached far inland and where dinosaurs roamed along endless shores. One of the most striking of these was the Western Interior Seaway, which once split North America from the Arctic to the Gulf of Mexico. Imagine a warm Cretaceous evening at its shore, the water calm and shimmering, reflecting a lavender sky. Herds of duck-billed hadrosaurs grazed nearby, while pterosaurs wheeled above, diving for fish that sparkled near the surface. Predators, both reptilian and avian, lurked along the edges, watching with patient stillness. This inland sea was not just water, it was an ecosystem that touched every life around it. A mainstream fact is that shallow seas tend to warm quickly and create humid climates. In the Cretaceous, the spread of inland waters made the world lush and green, with forests extending even into polar regions. Fossilized wood and leaves have been found in Antarctica, showing that dinosaurs once walked among forests there, under long polar days and nights. A lesser-known detail is that these inland seas left behind chalk, vast layers of white rock built from the remains of tiny plankton called coccolithophores. Their microscopic shells settle to the seafloor in countless numbers, compressing into stone over millions of years. Today, cliffs of chalk in England and Europe are silent monuments to those ancient seas, reminders that dinosaurs once lived in a greener, wetter world. Astrophysicists still debate how much cosmic influences played into these watery expansions. Some suggest that small fluctuations in Earth's orbit and tilt, magnified by tectonic drift, drove polar ice to retreat, allowing seas to spread. Others argue that volcanic outgassing, releasing carbon dioxide, warmed the world until ice vanished entirely. The interplay between celestial rhythm and earthly fire shaped the coastlines where dinosaurs grazed. Picture a night at the edge of the western interior seaway. The tide is high, lapping against fern-covered banks. The moon rises, larger than ours appears today, casting a silver path across the water. Insects hum, frogs croak, and somewhere nearby, the low bellow of a dinosaur echoes through the mist. Above, the Milky Way stretches wide, reflected faintly on the surface of the inland sea, as if two heavens had joined. For the creatures of that age, water meant life. Rivers flowing into these seas carried nutrients that fed plankton, which in turn nourished fish, which drew pterosaurs and marine reptiles. Inland, the moisture-nurtured forests that provided food for herds. When seas withdrew, grasslands or deserts replaced them, altering the balance of species. Dinosaurs adapted to both abundance and scarcity, their lives tied to the quiet breathing of the oceans. It is easy to think of dinosaurs as creatures of forests or plains alone, but their world was threaded with water as surely as our own. Every raindrop, every tide, every inland sea linked them to the sky above. The moon tugged at tides, the sun warmed currents, and the stars looked down upon waters that mirrored their light. In these inland seas, life was layered, tiny drifting plankton below, fish weaving between, reptiles gliding above, and dinosaurs watching from shore. The patterns of survival echoed the patterns of galaxies, each form filling its place, each movement part of a larger balance. And so, the Cretaceous seas were not boundaries but connections, binding land and sky, creatures of water and earth. Dinosaurs lived at these edges, drinking from rivers that led to inland oceans, hearing waves in the distance, and watching stars shimmer across mirrored surfaces. Their story was written as much in water as in stone, as much in tide as in time. From the soft shores of inland seas, we wander into the Cretaceous bloom, a time when the world itself seemed to flower. For hundreds of millions of years, plants had been dominated by ferns, cycads, and towering conifers. They clothed the land in green, but their reproduction relied on spores and wind, scattering pollen blindly across the air. Then, slowly at first, and then in sweeping abundance, flowering plants appeared. Angiosperms, as scientists call them, transform the earth into a place of colour, scent and nectar. Imagine a warm Cretaceous morning. The air is heavy with fragrance from fields of blossoms, their petals unfurling to meet the sun. Insects swarm eagerly. Beetles, flies, and the early ancestors of bees, drawn to nectar and carrying pollen between blooms. Dinosaurs wander through this new abundance, grazing not only on ferns and leaves but also on flowers and fruits that had never existed before. The world they knew was shifting into one richer, softer, and more diverse than anything their ancestors had seen. A mainstream fact is that angiosperms evolved around 130 million years ago and spread rapidly. Within a relatively short span, they overtook older plant lineages and reshaped ecosystems. Their seeds, protected within fruits, spread efficiently by wind, water, and hungry animals. This innovation gave them an edge that still defines our modern landscapes. A lesser-known detail is that fossilized flowers reveal delicate structures remarkably similar to modern blooms, suggesting that the earliest angiosperms already carried complex forms. Some may have been small and inconspicuous, hiding beneath ferns, while others opened widely to attract insects. These subtle beginnings eventually gave rise to everything from magnolias to grasses, changing not just diets but the very atmosphere. Angiosperms absorbed carbon with great efficiency, cooling the planet slightly and shaping climates in ways that guided evolution. Astrophysicists still debate whether subtle changes in Earth's orbit helped trigger this floral expansion. Perhaps longer summers and gentler winters created conditions that favoured plants able to exploit short bursts of warmth and pollination. Or perhaps the shift was simply evolutionary momentum, a cascade of advantages that spread once the first blossoms opened. The truth may lie in a quiet combination of both, cosmic rhythm and earthly invention. Picture a Cretaceous valley filled with bloom. Herds of hadrosaurs move slowly, their heads sweeping through fields of flowers, while smaller dinosaurs pick at fruits that have fallen to the ground. Insects buzz above petals of yellow, red and purple, carrying life between blossoms. Birds, already descended from feathered dinosaurs, flit among branches, pecking at seeds. The air itself hums with a new richness, a symphony of colour and scent layered upon the green that had dominated for ages. At night, the blossoms closed under starlight, their petals folding as the Milky Way arched above. The cycle of bloom and rest mirrored the cycle of day and night, sun and star. Dinosaurs slept in meadows now fragrant with flowers, while insects sought shelter in the folds of petals. The same photons that nourished flowers by day shimmered from stars by night, weaving a quiet thread between Earth's bloom and the cosmos beyond. The Cretaceous bloom carried more than beauty. It offered sustenance. Fruits provided nourishment for creatures that carried seeds farther afield. Pollination created webs of interaction between plants, insects, and dinosaurs. The world grew more interdependent, its rhythms more intricate. Each petal, each seed, was a step in an unfolding story that would continue long after the dinosaurs were gone. And so, in the quiet turning of Earth beneath the stars, flowers changed everything. They softened the world of reptiles, filled it with new scents and tastes, and laid the foundation for the ecosystems we know. Every garden today, every field of blossoms in spring, carries a memory of that Cretaceous bloom. It was as if Earth itself had decided to sing in colour, beneath skies unchanged, while dinosaurs grazed gently in its chorus. As flowers spread across valleys and meadows, another lineage was refining its place in the skies. The small feathered creatures of the Jurassic, once clumsy gliders, became in the Cretaceous true masters of flight. Their wings strengthened, their feathers lengthened and stiffened, their bones grew lighter and hollow. From uncertain beginnings among branches, birds emerged, carrying the legacy of dinosaurs into a new realm of air and wind. Picture a Cretaceous dawn. The first rays of sunlight strike, blossoms still damp with dew. From a tree's canopy, a small bird lifts into the air, its wings beating with surety. It darts among branches, plucking insects mid-flight, then glides above a meadow where hadrosaurs graze. Its call, sharp and quick, echoes across the valley. This is no longer a tentative leap between shadows. This is true flight, woven into the life of Earth. A mainstream scientific fact is that birds are direct descendants of theropod dinosaurs. Their skeletons carry unmistakable signatures: three-toed feet, wishbones, and feathers evolved from earlier reptilian scales. Every robin, hawk, or heron we see today is a living dinosaur, their lineage unbroken across deep time. A lesser-known detail is that many early birds still bore teeth and clawed fingers on their wings. Some could perch on branches like modern birds, while others retained traits of their dinosaur ancestors. Fossils show delicate feather imprints alongside sharp teeth, a reminder of the long transition. Over millions of years, these features softened into the beaks and wings we know today. Astrophysicists still debate how much cosmic events influence the bursts of avian evolution. Some argue that cycles of climate guided by orbital shifts opened niches for birds to flourish. Others suggest that sheer competition among feathered dinosaurs drove their refinement. What is certain is that the skies, once the domain of pterosaurs, grew richer with new voices and forms. At night, the flight of these creatures took on a different mood. Imagine a quiet evening by an inland sea. The moon rises, casting its reflection in silver across the water. A small bird launches into the night, wings gliding silently on the breeze. It hunts moths drawn to blossoms, its movements guided by starlight. Overhead, meteors streak briefly across the sky, their light mirrored on rippling waves. The bird moves effortlessly within this cosmos of light, as if the stars themselves were companions in its flight. Some early birds may have travelled long distances following seasonal changes. Just as modern migratory birds trace invisible paths across continents, their ancestors may have crossed valleys and seas in search of food. The constellations, constant and unchanging across lifetimes, may have served as quiet guides. Even today, some migratory birds are known to navigate by stars, sensing the patterns of the heavens as maps. Perhaps this instinct reaches back into the deep time of their origins. Meanwhile, pterosaurs still ruled the skies alongside birds. Some were vast, with wingspans longer than a small aircraft, soaring above coasts and seas. Birds and pterosaurs may have shared the same airspace, sometimes competing, sometimes dividing niches. One can imagine a twilight where a giant pterosaur glides high above, while flocks of small birds dart below, both silhouetted against a glowing horizon. The refinement of avian life was quiet compared to the thunder of giant footsteps, yet its significance rippled far into the future. For while the great sauropods and armoured giants would vanish, the birds would remain, carrying not only the form but the very soul of dinosaurs into our skies. So when we hear the call of a sparrow or watch a gull soar across the ocean at dusk, we are not only seeing the present, we are glimpsing echoes of the Cretaceous, when feathers grew strong, when flight became freedom, and when the sky filled with new songs beneath the same constellations we trace today. Through millions of years of flourishing life, the dinosaurs ruled the land, adapted to forests, plains, and shores. Yet their age was not endless. In deep time, endings often arrive as whispers first, then as sudden storms. For the dinosaurs, the storm came from the heavens, in the form of a wandering asteroid that struck Earth with unimaginable force. It is humbling to imagine that such a moment began far away, perhaps in the outer reaches of the solar system, where icy and rocky bodies drift quietly in the dark. A fragment of stone, dislodged by the gravitational pull of larger planets, began a long, unhurried journey toward the inner worlds. For millions of years it travelled unseen, its path guided by chance and orbit. And then, one day, its course intersected Earth. The object that fell was around 10 kilometers across, yet its impact carried the energy of billions of atomic blasts. It struck near what is now the Yucatan Peninsula, in shallow tropical seas. The moment it entered Earth's atmosphere, the sky blazed brighter than the sun. Air compressed before it, heating to thousands of degrees. Within seconds, forests ignited for hundreds of kilometers, and waves of fire swept across landscapes where dinosaurs grazed. A mainstream scientific fact is that this impact created the Chicxulub crater, more than 150 kilometers wide, still buried beneath layers of sediment. Shockwaves rippled through the planet, triggering earthquakes and tsunamis that spread across seas. The blast threw dust, rock and vaporized sulfur high into the atmosphere, blocking sunlight and turning skies dark for years. A lesser-known detail is that tiny glass-like beads called tektites rained from the sky in the aftermath. These droplets formed when molten rock was hurled upward and cooled as it fell. Fossil layers from that time still hold them, silent markers of a moment when the heavens struck the Earth. Some layers also carry iridium, an element rare on Earth's surface but common in asteroids, confirming the story of cosmic origin. Astrophysicists still debate whether the asteroid alone caused the extinction, or whether it coincided with vast volcanic eruptions in India known as the Deccan Traps. Perhaps both together darkened the sky and poisoned the air, overwhelming ecosystems. The exact balance is uncertain, but the outcome was clear. The Age of Giants ended. Picture the first nights after impact. Ash drifts through the air like snow, blotting out stars. The moon glows faintly red behind veils of dust. Dinosaurs, bewildered, move through forests lit by fires. Rivers run thick with debris. The hum of insects falters. The calls of birds grow quiet. The world itself seems to hold its breath. In those skies, meteors still streaked, galaxies still turned, and the Milky Way still arched overhead. The cosmos continued its rhythm, indifferent to the fate of creatures on one world. Yet for Earth, everything had changed. Plants withered without sunlight. Temperatures plunged. Chains of life that had endured for millions of years unravelled within decades. To us, this impact is both tragic and profound. It reminds us that chance rules as much as law in the universe. The same heavens that nurtured life with light and warmth could, with a single wandering stone, reshape it entirely. Dinosaurs, who had flourished through countless cycles of climate and change, met their silence in fire and shadow. And yet, even in this devastation, some seeds of survival remained. Birds took to the skies, mammals hid in burrows, and plants endured in soil. Out of the cosmic blow that ended an age, new beginnings would later rise. The asteroid strike was not only an ending but also a hinge in time, turning Earth's story toward a new chapter beneath the same unhurried starlight. After the heavens delivered their blow, the Earth entered a long season of shadow. The asteroid's impact had cast immense amounts of dust, soot, and sulfur into the sky, spreading a veil that dimmed the sun. Days turned grey, nights grew colder, and the rhythms that had once sustained lush forests faltered. Dinosaurs, who had endured countless cycles of change, now faced a silence they could not outlast. Imagine the world in those first months. Forests that once shimmered with blossoms now stood charred. Fields of ferns, once endless green, lay flattened beneath ash. The air itself was thick, carrying the acrid scent of burning. When the sun struggled through the haze, it cast only a dim orange glow, weaker than the light of dawn. Temperatures dropped sharply, and rains fell acid-laden, scarring soil and water alike. A mainstream scientific fact is that this period is often called an impact winter. With sunlight blocked, photosynthesis nearly ceased. Plants withered, plankton in the oceans died, and food chains collapsed from the bottom upward. Dinosaurs that relied on endless greenery to sustain their massive bodies found themselves in a world without harvest. A lesser-known detail is that fossilized pollen and spores from this time show a sudden dominance of ferns, known as a fern spike. Ferns were among the first plants to return after the devastation, their spores spreading quickly across barren soil. They rose in places where forests had fallen, marking the beginning of recovery even as most life struggled. Astrophysicists still debate how long the skies remained dark. Some estimates suggest months, others decades. Perhaps sunlight returned slowly, in waves of dim brightness, never quite enough to restore warmth. Volcanic eruptions may have prolonged the chill, mingling their gases with the asteroid's dust. Whatever the span, it was long enough to silence most of the great dinosaurs, leaving only the smallest, most adaptable forms to endure. Picture a herd of weakened herbivores wandering through a dying valley. Their once mighty steps are slower now, their forms gaunt. Streams run cold and muddy, their waters reflecting only a faint smear of light where the sun should be. Insects are fewer, birds quieter, predators scarce. The world itself seems paused, caught between the memory of abundance and the promise of something unknown. Meanwhile, in the oceans, devastation was just as deep. With plankton gone, fish populations collapsed. Marine reptiles, once abundant in inland seas, dwindled rapidly. The quiet beneath the waves mirrored the silence above. What life endured clung to hidden places, deep ocean vents, burrows in soil, seeds waiting patiently for better light. And yet, even in this shadow, the cosmos moved on. The Milky Way still spun, comets still passed, stars still bloomed and died. The quiet expansion of the universe continued, unhurried, indifferent. Earth's catastrophe was vast to those who lived it, yet only a moment in galactic time. Still, endings are never complete. While most dinosaurs fell into silence, a few threads of survival held firm. Small feathered birds weathered the cold, perhaps feeding on seeds that endured when foliage failed. Mammals, tiny and quick, foraged in hidden places, eating roots and insects. Crocodiles lingered in rivers, turtles in ponds, their patience outlasting storms of fire and shadow. Life bent but did not break. The impact winter slowly loosened its grip. Skies cleared by degrees, rains washed the dust, and light began to return. Green spread again, cautious at first, then bold. But the age of giants was gone. Where sauropods once shook the ground, silence lay. Where tyrannosaurs hunted, only shadows remained. For us, the memory is written in stone, iridium in boundary layers, shocked quartz, tektites scattered like glassy beads, fossil beds filled with sudden endings, creatures caught in collapse. These are the whispers left by that long night. And so, the age of dinosaurs closed in quiet shadow. Their long story, woven with tides, stars and time, faded beneath a sky that once again cleared to show the Milky Way. What remained was not emptiness, but the beginning of something new. When the skies finally began to clear, what remained was a quieter world. The great herds were gone, their thunder silenced. Predators that once ruled valleys and plains had vanished. Yet not all life surrendered to the darkness. Survivors endured in shadow, finding warmth and food where they could, carrying the spark of resilience into the next age. Among the most enduring were the small feathered dinosaurs, the lineage we know today as birds. Their bodies, lighter and more adaptable, may have given them an advantage. Many could feed on seeds, a resource that survived even when green plants withered. At night, they sheltered in hollows or under branches, their feathers insulating them against sudden chills. Imagine a small flock gathering on the branch of a charred tree, calling softly under a sky that had just begun to show stars again. They were the fragile continuation of a lineage that once filled the world with giants. Mammals also endured. Long before they rose to prominence, they lived quietly in the shadows of dinosaurs, often no larger than a rat or shrew. They hid in burrows, emerged at night, and fed on roots, insects, and whatever scraps they could find. When the asteroid struck, their small size and varied diets gave them a resilience the giants lacked. Picture a burrow beneath the soil, a small mammal curled in the dark, safe from falling ash, emerging when the air grew still. A mainstream scientific fact is that crocodiles and turtles also survived this great extinction. Their semi-aquatic habits and ability to go long periods without food gave them an advantage. Rivers and lakes became refuges where life could pause until conditions improved. A lesser-known detail is that some amphibians and even delicate freshwater fish endured, their eggs and larvae hidden in mud or icy pools. Fossil evidence suggests that wetlands and waterways became strongholds, where cycles of life continued quietly even as the larger world fell silent. These places, fed by groundwater and shielded from the worst of climate swings, acted as small sanctuaries. Astrophysicists still debate the precise timing of recovery. Some argue that ecosystems began to rebound within tens of thousands of years, while others suggest it took much longer for stability to return. Either way, in cosmic terms, the recovery was swift, life finding footholds where none seemed possible, much as galaxies reform after collisions. Imagine a Cretaceous twilight transformed into an early Paleogene dawn. The stars brighten in the clearing sky, their light no longer veiled by dust. A small bird rustles in the branches, then launches into flight, wings catching the first rays of returning sunlight. In the undergrowth, mammals scurry, their eyes reflecting starlight. The world is smaller now, quieter, yet alive. The resilience of these survivors is a reminder that life endures in humble forms. Where giants fell, sparrows rose, where titans starved, mice endured. From the perspective of the cosmos, the shift was subtle. The Milky Way spun on, comets passed, and ancient light continued its journey. Yet on Earth, everything had changed. The great dinosaurs had passed into memory, their reign ended. But their story was not erased. It lingered in bones buried beneath sediment, in birds that carried feathers skyward, in seeds that sprouted anew. Survival had taken unexpected shapes, and those shapes would guide the course of Earth's next chapter. To drift with this thought is to feel the quiet humility of time. The mightiest creatures of an age may vanish, yet small ones endure. Life is not always measured in strength or scale, but in adaptability, patience, and quiet resilience. And so, under the stars that shone both before and after, survivors carried the thread forward, weaving a new age beneath the same velvet skies. As the long night gave way to dawn, Earth began to rebuild itself. The Paleogene world rose quietly from the ashes, its landscapes reshaped by silence and resilience. Gone were the great herds of sauropods, the armoured stegosaurs, the towering predators. In their place, forests spread again, rivers carved new paths, and life stitched itself back together in humbler forms. Imagine a hillside in the early Paleogene, the air fresh after a night rain. Young trees, not yet tall but reaching eagerly, fill the slope. Birds flit among branches, their calls sharp and new against the quiet. On the ground, small mammals emerge, noses twitching, paws brushing damp leaves. These creatures, once shadowed by giants, now move freely through a world of open possibility. A mainstream scientific fact is that mammals diversified rapidly after the extinction. With dinosaurs gone, niches opened across ecosystems. Herbivores grew larger, predators became more varied, and early primates began their slow ascent. Within a few million years, the foundations of the modern mammalian world were in place. A lesser-known detail is that some birds also radiated widely in this new world, especially waterfowl and shorebirds. Fossils show that ducks, crane, and other familiar forms were already spreading. Lakes and rivers, which had served as refuges during the extinction, became cradles for avian expansion. Their calls, echoing at dawn, marked a new chapter in the song of life. Astrophysicists still debate how stable Earth's climate was in this period of recovery. Some evidence suggests sharp swings, brief warm spells and sudden cool dips, perhaps influenced by lingering volcanic activity or small orbital shifts. Life, fragile yet determined, adapted to each turn, filling valleys and coasts with new forms. Picture a Paleogene forest at dusk. The sun sets behind young canopies, casting long shadows. Small horses graze quietly, no larger than dogs. A bird of prey circles overhead, its silhouette dark against a sky slowly filling with stars. In the undergrowth, rodents scurry, followed by early primates climbing branches. The world is different, but it is alive, humming with possibilities, and above, the cosmos remained constant. The Milky Way arched across the night, Galaxies collided far away, and supernovae scattered elements into the void. Dinosaurs had lived and fallen beneath those same skies, and now new creatures inherited the stage. The heavens offered no judgment, only continuity, a reminder that life on Earth is but one story among countless others written in starlight. The resilience of Earth is profound. After every collapse, it finds ways to renew itself. The extinction of dinosaurs was not the end of life, but a turning point. From it rose the mammals that would one day give rise to us, the birds that still carry echoes of reptilian ancestors, and the plants that continue to blanket the land in green. When we walk through forests today, hearing birdsong in the morning or watching mammals move through undergrowth, we are listening to the Paleogene's legacy. Each sound, each motion, is part of a line that began when Earth rebuilt itself after the shadow. And so, in the quiet dawn of the Paleogene, the world began again. Giants were gone, but their absence allowed new voices to rise. Beneath ancient starlight, life found its way forward, weaving new patterns into the fabric of time. Though the great reptiles had vanished, their presence never fully left the Earth. For among the survivors were birds carrying with them the unmistakable marks of their ancestry. Every feather that shimmered in dawnlight, every call that echoed across valleys was a quiet continuation of the dinosaurs' story. In this way, they did not truly disappear, but changed shape, shrinking from titans of the land into messengers of the sky. Imagine standing in a meadow at sunrise. A small bird lifts from a branch, wings flashing gold in the early light. Its flight is swift, its song bright. Yet hidden within its bones are the same structures once carried by raptors and hunters of the Mesozoic. Its wishbone, its three-toed feet, even the hollow bones that lighten its body are echoes of ancient forms. Each bird alive today is, in truth, a living dinosaur. A mainstream scientific fact is that birds are the only lineage of dinosaurs to survive the Great Extinction. Paleontologists now classify them as avian dinosaurs, while the others are called non-avian dinosaurs. In technical language, dinosaurs never truly ended. They simply shed their larger earthbound shapes and took to the air. A lesser-known detail is that some early post-extinction birds were surprisingly large. Fossils reveal seabirds with wingspans rivaling modern albatrosses, soaring above young Paleogene oceans. On land, others grew long legs, striding like cranes or herons. These forms remind us that survival was not only about hiding, but also about finding bold new roles in a changed world. Astrophysicists sometimes draw parallels between survival on Earth and survival in the cosmos. Just as small, adaptable species endured when giants failed, so too small galaxies often survive cosmic collisions while larger ones merge or fade. The universe seems to favour resilience in humble forms, whether among stars or living creatures. Picture a Paleogene twilight. Insects hum, mammals forage in shadows, and birds settle on branches, their feathers glowing faintly under a rising moon. One bird tilts its head to the sky, its eyes catching starlight. It cannot know that its ancestors once filled the earth, nor that its descendants will one day spread to every continent. But in its quiet presence, the age of dinosaurs endures. Even today, when we hear the call of a crow or watch the spiral of a hawk, we are listening to echoes of a time long past. The resilience of birds is remarkable, carrying the memory of an age that otherwise slipped into silence. They are both ancient and present, both past and now. Dinosaurs may have fallen from dominance, but through birds they still fill the air around us. Their songs drift across mornings, their migrations span continents, their feathers catch the same starlight that once fell on their ancestors. We live in their company still, whether we notice or not. And so, the rise and fall of dinosaurs is not a closed story. It lingers in flight and feather, in song and shadow. To look at a bird is to look at deep time made present, at the endurance of life written softly in wing beats beneath the same velvet sky. When we uncover the bones of dinosaurs, we do more than study fossils. We touch a thread that stretches through deep time, linking Earth to the cosmos. Each bone, each imprint in stone, is a frozen moment, a whisper from an age when giants walked beneath starlit skies. As paleontologists brush dust from fossils, they reveal not only creatures of the past, but also the patient work of the universe itself. Imagine a quarry in quiet sunlight. Layers of rock stacked over millions of years hold the remains of creatures long gone. A rib, curved and fragile, lies half buried. Nearby a tooth glints faintly, still serrated after eons. These are the fragments through which we reconstruct whole worlds. We read their story in stone, much as we read the stars in the night sky. Both are archives of time, one beneath our feet, the other above our heads. A mainstream scientific fact is that fossils form when bones and shells are buried quickly under sediment, their organic material replaced by minerals over long spans. What survives is not the bone itself, but a stone cast, holding the shape of life. These processes preserve not only skeletons, but also impressions of feathers, skin, even the outlines of muscles. A lesser-known detail is that some fossils capture astonishing delicacy, pigments preserved in feather imprints that reveal colours once thought lost. In certain Chinese fossils, shades of black, brown, and even iridescent blue can be inferred, allowing us to picture dinosaurs with far more vibrancy than stone alone suggests. These colours, shimmering under Jurassic or Cretaceous light, remind us that dinosaurs lived not in dull tones, but in palettes shaped by survival and display. Astrophysicists still debate how cosmic events influenced fossil preservation itself. Some argue that asteroid impacts and volcanic eruptions created sudden burial conditions, sealing creatures in layers of ash and sediment. Others suggest that climate swings dictated where and when fossils could form. In truth, the record we have is partial, shaped as much by chance as by science. Picture a dig site under a wide night sky. Paleontologists set down their tools as evening falls. They look upward, seeing the Milky Way blaze across the heavens. The same stars once shone over the creatures whose bones they now hold. In that moment, past and present converge, connected by light that has travelled for thousands of years and by stone that has held memory for millions. Our fascination with fossils is not only scientific but also deeply human. To hold a dinosaur bone is to feel time compressed, to sense the vastness of history beneath our feet. It humbles us, reminding us that our own story is brief in comparison. Just as photons from ancient stars reach our eyes tonight, so too do fossils carry echoes from distant ages, bridging the abyss of time. Dinosaurs may have fallen, but in stone and starlight they remain with us. Every fossil is a page, every excavation a reading, every discovery a new stanza in the poem of Earth. To gaze at them is to listen to the patient whisper of ancient light and ancient life, woven together in the fabric of time. And so, we walk through museums, fields and quarries not only as scientists but as travellers through deep history. Fossils beneath us, stars above us, both are records of what was, both are invitations to wonder at what endures. The story of dinosaurs from their small Triassic beginnings to their Cretaceous silence is one of deep time woven with starlight. Their rise and fall remind us that life on Earth is inseparable from the rhythms of the cosmos. Giants may stride across plains, seas may bloom with life, and flowers may turn their faces to the sun, yet all are carried along by cycles of orbit, tilt, fire, and chance. Imagine the Earth as it was in their prime. Herds moved across continents beneath skies clear of any human trace. The moon glowed larger, tides pulled stronger, and constellations mark the passage of nights. Now picture the Earth as it is today. The giants are gone, but their legacy lingers in feathers that flutter across branches, in fossils that rest in stone, and in our imagination, which keeps their presence alive. A mainstream scientific fact is that dinosaurs ruled for more than 160 million years, far longer than humans have existed. Their span is a reminder of endurance, yet also of impermanence, for even the longest reigns can fade. A lesser-known detail is that the very same impact that silenced them cleared the way for mammals to rise, leading, in time, to us. Without their fall, our story might never have begun. In this way, endings and beginnings are twined, as inseparable as night and dawn. Astrophysicists still debate whether life elsewhere in the universe has faced similar turns, worlds where creatures may have risen and fallen beneath different suns. Perhaps countless planets carry their own stories of rise, bloom, and silence. The cosmos is wide, and we know only our own thread. Picture yourself now beneath the night sky. The Milky Way arches quietly above, its stars unhurried. The same starlight once shone upon dinosaurs as they grazed, hunted, and slept. It shines on us now, and it will shine long after. Dinosaurs are gone, yet they are not forgotten. They live in birds, in fossils, and in our wonder. They live in the deep fabric of time, an echo in eternity. And so, the rise and fall of dinosaurs becomes part of a greater story. The story of a universe that creates, transforms, and renews. A story written in stars, in stone, and in the quiet turning of earth beneath a velvet sky. Now, as we leave this long journey, let us slow our breathing and rest in the stillness. We have wandered with dinosaurs across forests and plains, seen them rise to greatness, and watched them fade into silence. We have stood beside inland seas, beneath volcanic skies, and under the glow of countless stars. Through it all, we have remembered that their story is also Earth's story, and that Earth's story is bound to the wider cosmos. The stars above us tonight are the same stars that look down on them. Ancient light drifted across space, settling softly on their scales, their feathers, their bones. That same light now settles on our own skin as we gaze upward, a bridge across millions of years. In this way, we are not separate from the dinosaurs, but connected, through starlight, through time, through the earth we share. Take a moment to picture the quiet images once more. A sauropod's shadow against a twilight sky. A feathered creature gliding between branches. A bird rising from ashes into morning light. These visions remind us of resilience, of endings that are also beginnings, and of the patient unfolding of deep time. Let your thoughts drift like ancient photons, wandering slowly across the velvet dark. Let your breath lengthen, as if in rhythm with the slow turning of the Milky Way. Life comes and goes, worlds bloom and fade, yet the cosmos continues in unhurried expansion. And within that vastness, there is always room for quiet wonder. So rest now, under starlight older than Earth itself. The dinosaurs have walked their path and we walk ours, but both are part of the same eternal night.